Picking up where we left off last time, what we're going to do is state this is equation 1 and this is equation 2. Okay? And so the first step is to recognize that what we have are two linear equations, and we solve them in exactly the same way we would solve them in linear algebra. So there's a nice little trick we can do to make this simpler. We're going to eliminate the x2 term. Okay, so we want to add these two equations into each other so that these terms cancel out one another. Okay, so the way to do that is you can imagine we're going to multiply the top equation, right? So first equation, we're going to multiply by s, okay? And the second equation, we are going to multiply by -3, okay? So after we carry through s multiplication of the first equation and -3 multiplication of the second equation, we then will have every term in the proper form and then add them together. We'll get the cancellation we're looking for. And what you guys should end up getting, and you can check this yourself so you can follow along, but the final answer we will get is s squared minus 3 times s minus 18, okay, times x1 of s, and it's all going to be in terms of x1 since the x2 term cancels out from our little manipulation. And this will be 2 plus s, okay, plus 3s squared, all right, plus 3, all divided by s squared, okay? So that's what you get after you perform that correctly. And then we solve for x1, and this is going to lend us the following. We get x1 of s will equal the following fraction. The numerator will be s cubed, okay, plus 5s squared, like this, plus 3, all right? And the denominator is going to be s squared times s plus 3, okay, times s minus 6, all right? So partial fractioning is what you're going to have to do in this situation, okay? And in your final exam, this is a very real possibility as well. You probably will likely have to use partial fractions to get a solution. So make sure you brush up on that and review how to do partial fraction decomposition. It will likely be part of your final exam. If you do the partial fraction decomposition correctly, you get x1 of s, and that's going to equal 1 over 108. That's the constant we can pull out. And this will be 133 divided by s minus 6, okay, minus 28 divided by s plus 3, all right, plus 3 over s minus 18 over s squared. So at this point, what I recommend for you guys is actually pause the video and try to use partial fraction decomposition to get to this solution, okay? That would be excellent preparation for your final, just so you guys have the necessary practice to turn the above expression into our final expression that we have right here. Okay, that's going to be essential for you to know how to do. So practice that. If you have any questions, please send me an email and I'll help you guys through it. So now that we've arrived at this point, we're still in a Laplace transformation scenario. So now we need to back transform or use the inverse transformation to give us the solution. And so what that means, using the inverse transform, our first solution is going to be x1 of t. Notice the transformation from s to t. That's an indicator that we're going back. And that's going to be 1 over 108 as the constant. And 1 over s minus a, if you look at your Laplace transformation table, is going to tell you that's e to the at. Okay, so a here is 6. Our constant's 133, so we pull out the constant first. So 133, and then this will be e to the 6t. Simple. So the next one again, we have 1 over s minus a, but in this case a needs to be -3 to account for the positive here. And our constant is -28, so this is -28, and this is going to be e to the -3t. All right. The next one, if you look at your Laplace transformation, it's just the constant itself. So 1 over s just means 1, right? So it's just 1 times the constant, so that's going to be 3, nice and easy. And then we have s squared, and you guys know from your Laplace transformation table that's t. Then you pull out the constant, right? So it's going to be -18, that's our constant, times the inverse transformation, like I said, 1 over s squared. If you look at your table, the inverse transformation is simply t. Okay? And that would be your first solution. All right, now we need to get the second solution, which is a little more involved. It requires integration, but I think you guys would find it to be more straightforward. So to find the second solution, we go back up and we eliminate x1. Okay, so that's your first step. So go back and eliminate x1 to find the transform for x2. And sometimes we would need to do that, but though you could do it that way, there is a better way. In this case, notice that the second differential equation is actually the following, right? So remember, we actually have this form here. x2 prime equals -6 times x1 minus t. That's what we had. So instead of going through the rigmarole that you see here with partial fraction decomposition, although you could do it that way and you will get the same answer, you can actually simplify your life a bit just by solving for x2 by integrating both sides. And so this will be the integral of -6 x1 minus t dt. All right, so let's go ahead and take that integral. And what we end up with is the following. We get x2. And what we do with that, actually, so what do we do for x1? So you probably could guess we're going to plug in our solution for x1 right there. So that's what we're going to do, and then solve the integral and obtain x2. And if you do this correctly, you get x2 of t, and that's going to equal -1 over 18, okay, multiplied to the integral of 133, right? And this comes from plugging in our first solution, e to the 6t, all right, minus 28 e to the -3t, all right, plus 3, all with respect to t. Okay. So if you plug it in, you'll notice that the t's will cancel, and we get this expression here. Okay. And so what this is going to equal now is the following. When you take the integral, you'll get -1 over 108. Okay. And here, if you integrate each piece independently, you will have 133 e to the 6t, okay, plus 56 e to the -3t, okay, plus 18t plus c, okay. So of course, when you divide by your constants, you'll notice there is a particular value you can pull out, and you'll multiply that to the outside to have this nice expression you see within. All right. And in our next video, or I think I have, no, we have time. So let's finish this problem up within the time that we have with this video. Now what we do is we, excuse me, reapply the second initial condition to get the constant of integration, right? We need this piece. So to do that, by applying the second initial condition, just like we did with the first one, we'll have -1 equals -1 over 108, all right, multiplied to 133 plus 56, okay, plus c, All right, and all of this is going to imply that C equals 3/4. All right, so that's good news. So therefore, the second solution becomes, right, so this implies that x2 equals, and this will be minus 1 over 108, and this will be 133 e to the 6t, okay, plus 56 e to the minus 3t plus 18t minus 81. All right. So putting this all together, we have our two solutions for our system of differential equations. We have x1 of t, which we found was 1 over 108 times 133 e to the 6t minus 28 e to the minus 3t, right, plus 3 minus 18t. Okay, so this was x1 and this is x2. And these are the two solutions you would write as your final answer for this problem. All right, be sure you guys study this problem carefully. I would recommend you go through all the algebraic steps and all the calculus steps and reproduce these values. If you can understand this problem completely, that's great preparation for at least one of the 6 problems that will be on your final. So be sure you study these set of lectures very carefully, take good notes, and also work out several of the results that I've shown you with this problem. Okay? Well, that's it. Next video, I will show you the problems on your final and the kinds of steps and procedures I expect you will know. Stay tuned.